Good morning. I'm Denise Wardrop. As chair of this study and of this committee briefing, I'd like to welcome everyone to this meeting of the National Academies Committee on Independent Scientific Review of Everglades Restoration Progress. The task being undertaken by this committee is to produce a biennial report that reviews progress achieving the natural system restoration goals of the CERP and discusses scientific and engineering issues that may impact progress. The committee's report is expected in November 2022. Today's meeting will focus on the performance of stormwater treatment areas in support of CERP progress. And with that, I'll ask the committee members that are here to introduce themselves. I'll call on you by name and you can pop in and let us know your name and affiliation. So Alan, if you can start us off.
Thanks, Denise. Al Steinman, Director of the Honest Water Resources Institute at Grand Valley State University.
Okay. Charles?
Charlie Driscoll, Syracuse University.
Christopher?
Christopher Burke, President and CEO of Christopher Burke Engineering and on the faculty at University of Illinois, Chicago.
Okay. I'm Denise Wardrop. I'm from Penn State University, the Department of Geography, and also with the Chesapeake Research Consortium. Bill?
Good morning, Bill Bogus, Emeritus Professor of Environmental Economics at Oregon State University.
Ehab?
Good morning. My name is Eaa Planning. I'm from Tulane University, Department of River Coastal Science and Engineering.
And Ramesh?
Ramesh Reddy. I'm from University of Florida.
And Jeff?
Hi, I'm Jeff Walters from Virginia Tech.
Okay, and if there's anyone on, oh, Deirdre?
Yes, Deidre Gibson, Chair of the Department of Marine and Environmental Science at Hampton University.
All right, if I've missed anyone on the committee that has joined, please introduce yourselves. Okay, thank you. With that, before we kick off the first session, I want to note that this is an open on the record session. It is being live streamed and it will be archived for later viewing after the event. We will not take questions from the audience or public comment at this meeting, but you are welcome to submit public comment in writing to the study director, Stephanie Johnson at sjohnson@nas.edu. This meeting is being held to gather information to help the committee conduct its study. This committee will examine the information and material obtained during this and other public meetings in an effort to inform its work. Comments made by individuals, including members of the committee, should not be interpreted as positions of the committee or of the academies. And in addition, committee members typically ask probing questions, and that means sometimes they're clumsy, in these information gathering sessions that may not be indicative of their personal views. The committee will deliberate thoroughly before writing its draft report. Moreover, once the draft report is written, it must go through a rigorous review by experts who are anonymous to the committee, and the committee then must respond to this review with appropriate revisions that adequately satisfy the Academy's Report Review Committee and the NAS president before it is considered an official Academy's report. Therefore, observers who draw conclusions about the committee's work based on today's discussion will be doing so prematurely. And after those formal remarks, let me just say that in simpler language, what we as the committee hope for is simply trying to determine where we can be most helpful in moving the effort forward. To do that humbly, we recognize that you are the experts. And so what we want to do is understand what it is you see from your perspectives. Our questions are the only way we have to help us do that. So be patient with us and give us time. And so with that, we'll move on to our first session, which is legal, regulatory, and implementation context for water quality in CERP. We're going to start off with a video by Dan Scheit from EPA. That's been pre-recorded. Eric will play that. We'll then have Ken Bradshaw from the Corps to help us answer some questions. And I understand that Becky Allenbach of EPA is also on deck to help out. So with that, Eric, if you'd like to pull up Dan's presentation.
Good morning. I'm the senior scientist for Everglades of South Florida in the EPA Region 4 Water Division. I have been working on Everglades phosphorus since 1982. If you have any questions about today's presentation, feel free to email me or give me a call. Let's talk about Everglades phosphorus requirements that are relevant to CERP and the STAs. The overarching goal of these phosphorus requirements is to provide water quality that is consistent with the Federal Clean Water Act. The Miccosukee Tribe of Indians of Florida and the Seminole Tribe of Indians were both approved by EPA for treatment in a manner similar to states for administering sections of the Clean Water Act, including water quality standards. There are 8 phosphorus requirements in today's presentation. Why so many? Well, different places and goals. They were developed from 1992 to 2012. Most of these requirements have had to be addressed already in planning efforts or in Florida or federal permits required in order for CERP projects to proceed. All numeric phosphorus marsh requirements use an annual geometric mean in order to minimize the influence of high phosphorus concentration values. All numeric phosphorus requirements at water flow structures use an annual flow-weighted mean that weighs phosphorus concentration data by the volume of flow. The first numeric phosphorus requirements for the park are found in the Federal Court Moreno Consent Decree, Appendix A. These apply at the inflows to the park, or at the door, so to speak. The goal is anti-degradation, maintain the water quality that existed when Florida designated the park as an outstanding Florida water in 1979. Outstanding waters are waters designated worthy of special protection because of their natural attributes. A technical team was formed. We arrived at 8 parts per billion long-term limit for shark slip for inflows from the north, shown at the red dots. The limit varies annually from 7.6 to 12.8, based on a relationship between phosphorus and flow volume. And then inflows on the eastern side of the park at Taylor Slough and the coastal basins have a long-term limit of 6 and annual limit of 11. The scientific derivation relied on 78 to 90 baseline data for Shark Slough, 84 to 90 baseline data for Taylor Slough, and the technical references are in the last slide. The assessment is performed annually by South Florida Water Management District at 13 structures. The first numeric phosphorus requirements for the refuge were developed at the same time and are found in the Moreno Consent Decree Appendix B. The goal also was anti-degradation. The long-term level requirement is 7 parts per billion. The annual level varies from 7 to 12 based on the relationship between phosphorus and water level. Baseline data from 78 to 83 were used to derive these levels. And the assessment is annually by the Water Management District at 14 interior marsh stations shown in the red dots on the right. Next, we have the Seminole Tribe Big Cypress Federal Reservation. They do not have a numeric phosphorus standard. Numeric is under development now using Clean Water Act funding from EPA. Their standard is a narrative. In no case shall nutrient concentrations be altered so as to cause an imbalance in natural populations of aquatic flora or fauna. applies to tribal surface waters, including wetlands and canals, adopted by the tribe in 1997, approved by EPA as a water quality standard. Goals are anti-degradation and also recreation, propagation, maintenance of a healthy, well-balanced population of fish and wildlife. Scientific derivation, the tribe simply adopted Florida's nutrient narrative standard, and the tribe does the assessment using Clean Water Act funding from EPA. The Miccosukee tribe, Everglades Federal Reservation, has a 10 part per billion phosphorus standard, the first numeric phosphorus standard for the Everglades and the first for a marsh in the U.S. It applies to marsh and canal locations in tribal waters, was adopted by the tribe in 1997 and approved by EPA. Goals include anti-degradation, maintain water quality consistent with the tribe's designation of the Everglades marsh within their federal reservation as outstanding Miccosukee waters. Other goals: preservation of natural populations of native plant and animal communities, preservation of the ridge and slough and tree island landscape, propagation of fish and wildlife, hunting, fishing, frogging, and airboating. The scientific derivation was an Everglades literature review. Assessments are performed by the tribe. The Everglades Protection Area, the Refuge Water Conservation Areas 2 and 3 in the park, also have a 10 part per billion phosphorus standard, adopted by Florida in 2003 and approved by EPA. This was a numeric interpretation of the imbalance narrative that nutrients shall not cause an imbalance in natural populations of aquatic flora or fauna. Also, fish consumption, recreation, propagation, and maintenance of a healthy, well-balanced population of fish and wildlife. The scientific derivation was an extensive four-pronged approach. Everglades marsh and mesocosm phosphorus dose response studies, marsh transects, and an EPA phosphorus concentration reference method. Tens of millions of dollars were spent on this phosphorus threshold research. The assessment is performed annually by DEP in the Water Management District. A four-part test applied at 13 impacted stations, shown in red, and 44 unimpacted stations, shown in green. Each station has an annual 15 part per billion cap. The park is different. It uses the Moreno Consent Decree Appendix A limits at inflows, shown in slide 3. This brings us to the stormwater treatment areas. The STAs that discharge into the Everglades have a phosphorus discharge limit. It was adopted in 2012, referred to as a water quality-based effluent limit, or QBEL. It's found in the EFA and NPDES permits issued by DEP for the STAs. The goal is to meet 10 at end of pipe at the STA discharges. There is a 2-part annual requirement at each STA. Shall not exceed 19 parts per billion in any year, and shall not exceed 13 in more than 3 years out of 5. Scientific derivation: the STA annual discharge data from 1996 to 2010 were rescaled to 10 parts per billion. At each STA discharge, 10 part per billion geometric mean is equivalent to a 13 part per billion flow weighted mean, so that's why you see the number 13 instead of 10. The assessment, and this is important, water quality standards are not yet met, but the first assessment of the QBEL begins with May 2026, and that first annual year will be May 2026 to April 2027. Let's look at a specific example in CERP, the Western Everglades Restoration Plan. Planning is underway. Objectives include restore the quantity, quality, timing, and distribution of fresh water, The current planning alternative proposes 2 SDAs shown in yellow on the right. The SDA discharge planning target is 10. Planning includes meeting downstream phosphorus water quality standards for the Seminole Tribe of Indians, the Miccosukee Tribe of Indians, Big Cypress National Preserve, Everglades Water Conservation Area 3, and Everglades National Park. Let's take all these phosphorus requirements and put them on a single map. Beginning with Loxahatchee National Wildlife Refuge, they have the 10 part per billion Florida standard, as well as the 7 limit in the Moreno Consent Decree.
Recording in progress.
Water Conservation Area 2, 3, and the park also have Florida's 10 part per billion water quality standard. The park also has the inflow limits from the north of 8 part per billion and 6 on the eastern side from the Moreno Consent Decree. Big Cypress National Preserve has a no imbalance narrative. The Miccosukee's federal reservation in the Everglades has a 10 part per billion standard. The Seminoles reservation has a no imbalance narrative standard. And then also you have outstanding waters shown by the asterisks to represent anti-degradation. Florida designated the refuge, the park, and Big Cypress as outstanding Florida waters. Miccosukee has designated the Everglades portion of their reservation as outstanding Miccosukee waters. And the Seminole has designated portions of their reservation as outstanding Seminole waters. And then in the yellow at the top, you see the SDA discharge limits, equivalent to 10, assessed annually at 13 and 19. This concludes the presentation. Thank you.
Okay, with that, I will sort of kick it off with a question that I think Ken can answer. And so are there CERP actions and or operations that cannot proceed without achieving the Q-Bell at STA discharges? And if so, what are they? And Ken, maybe you can start off your remarks with addressing that question.
Sure. Good morning, everybody. My name is Ken Bradshaw. I'm with the Corps of Engineers here in Jacksonville District. I'm in the Planning and Policy Division as right now acting section chief for South Florida South Florida Restoration Project, not Water Management District. Sorry. And so, yeah. So to get to that first question, I kind of want to start with a little bit of the CERP authorization, and kind of the assumptions in the Yellow Book are that the Clean Water Act and any state and tribal water quality standards are being met for their existing use classifications. So this assumes that all reasonable measures within the watersheds are already in place, that the waters that are being received by the Central and South Florida system are of sufficient quality to meet water quality standards. And then as CERP projects are, I guess they go through authorization, they go through design, they're meant to be consistent with applicable water quality standards. So in CEP and EAA in particular, these are designed to be consistent with water quality standards and also not interfere with the state's independent efforts to meet restoration strategies and their requirements under the Everglades construction project and associated permits. With CEP, and I guess I'm focusing on CEP just because that really is bringing where the water is being brought into those Q-Bell limits that Dan discussed, and kind of as it moves south into the other areas in the central flowway that where there are water quality standards. CEP itself is authorized to depend in part on the STAs that already exist by the state, and EAA in particular. And it's designed to be consistent with water quality. The EAA again designed to be consistent with water quality standards. But since it's relying on those in part on the excess capacity, we have to, before the federal government can work the cost share in the projects, the water quality standards have to be met in those locations. And so, to get at the question of what can or can't proceed without achieving the QBEL at the STA discharges, the simple answer is that restoration strategies and the associated water quality standards for that have to be met before we can move forward with the operations of most of the CERP EAA phase projects. And I'll get to a little more of as it relates to the CERP EAA phase. I have a slide at the end of my presentation at 11:30 that kind of goes into the more specific examples of how EAA phase in particular can move forward.
Okay, thanks, Ken. Committee members, if you will raise your hands, I can call on you to ask questions. Phil, go ahead.
Ken, your answer to this may well be simply a reference to where I can find the information, but converting from geometric means to arithmetic means or flow-weighted arithmetic means depends a lot on the variability, not just in the water quality, not just the discharge. So how well researched was the attempt to convert from 10 part per billion geometric to 13 part per billion flow weighted?
So, I think that's a question more appropriately sent to Dan Scheidt. I think in his presentation, he did reference I want to say it was a 2012 publication of how that analysis was done. But I think that's more of an EPA related scientific analysis question. So I would refer you to Dan for that.
Thank you.
Mm-hmm. Bill, did you have a question or you lowered your hand?
I haven't figured out how to look. There we go. I was going to
no,
I'm going to delay.
Sorry about that.
Delay my question for Ken until his next presentation because it really has to do with EAA, reservoir STA, and something he said here. So I'll wait till then.
Okay, thank you. Jeff?
Yes, thanks, Ken, for your presentation. I want to make sure I understand exactly what the dependency of CEP is on STAs. Is it the ability to add new water? So construction can proceed and things can be done, but new water can't be added to the system until the QBEL is met. Is that right?
Yes, essentially no new water can go through existing state facilities until the QBEL is met, and the state has demonstrated compliance with the relevant water quality standards. That's correct.
Thank you.
Alan, and then Jennifer?
Thanks, Ken. Is there any pending litigation that you're dealing with right now regarding these flows and discharge limits?
There is pending litigation on the EAA and I believe on a lake, but that's about the extent I can speak to that.
All right.
Jennifer?
Hi, I just wanted to clarify maybe a couple of things. And the way that Ken is describing sort of some of the constraints, I'm not sure that we would describe them the same way. And so I wanted to maybe give another additional perspective. So when it comes to moving forward with CERP, we don't see that there is any conflict between moving forward with CERP and the QBEL requirements. We understand that the Corps of Engineers and the federal government has some concerns about how they will participate in cost share in particular. And so that is very different from our perspective about cost share versus being able to move forward with CERP. And so I want to add that clarity that there is a very well-organized, well-defined framework that has to do with the regulatory requirements, and the state will meet those regulatory requirements. And we are putting forth massive efforts, both in terms of personnel resources and financial resources, in order to ensure that we are meeting those. And we are looking forward to describing all of the work that we're doing and all the successes that we're having, and how we are on a very deliberate schedule in order to meet all of those requirements. And we are on the cutting edge of science and innovation when it comes to those things. And Cassandra's presentation a little bit later will give you all of that context. But as we move forward with CERP, we are fully committed to all of those regulatory requirements. But when it comes to timing and some of the things that I think Ken will discuss more at 11:40, we see that more as a cost share issue than a progress issue.
Thank you, Jennifer. Any other questions from the committee? All right, knowing my fellow committee members and that they're going to have lots of questions as we proceed, I'm going to go ahead and go to the next, even though we're just a couple minutes early, on to the next section, which is the STA performance overview. Cassandra Armstrong from the South Florida Water Management District has agreed to give us a presentation, and we will have a discussion afterwards. So Cassandra?
Good morning, everyone. Am I coming through loud and clear?
Yes, you are.
Fantastic. All right, let me get my slide working here. There we go. So good morning, everyone. I am Cassandra Armstrong. I'm the section administrator of the Water Quality Treatment Technology section here at the Water Management District. My section is responsible for implementation of the Restoration Strategy Science Plan, tracking STA performance, and advising on operation and management issues. So there are 5 Everglades STAs and 2 FEBs with 1 in the works. STA 1 East, which is here, treats water from the C51 basin and the L8 basin, which is a mix of agricultural and urban water. And STA 1 West here treats runoff from the S5A EAA basin, which is mostly agricultural. Both of them discharge into Water Conservation Area 1, which is also known as the Loxahatchee National Wildlife Refuge. STA 2 and 3-4 treat runoff from S6, 7, and 8 EAA basins, which is mostly agriculture, and discharge water into Water Conservation Area 2A and 3A. The A1 FEB, which is here, provides both STAs water. Over in the west, there's STA 5-6, which treats water from the C139 basin, which is mostly agriculture. STA 1 East, West, 2, and 3-4 can receive lake water, and a connection to STA 5-6 is in the works. These STAs were designed to operate within the regional flood protection system and must provide flood protection to the upland areas. So the general premise of an STA and how it functions is that water will flow into an emergent dominant area, particulate will fall out, and the plants will absorb phosphorus through their roots from the soil. Litter is produced and then falls down to the soil, making new soil and storing phosphorus. As concentrations in the water drop, some phosphorus may flux out of the soil, and this is referred to as internal loading. As the water moves into STA-dominated areas, SAV absorbed phosphorus from the water column. Periphyton also plays a very large role in phosphorus uptake. The high photosynthesis in this area raises the pH of the water, causing calcium to participate out with the phosphorus. This further reduces the water column concentration. So the front end of an STA is more of a physical removal, and the back end of the STA is more of a biogeochemical removal of phosphorus from the water. FEBs have recently been added to the treatment train, reducing the phosphorus loading going into the STA, as well as moderating the flows into the STA, resulting in less plant stress from high water depth and flow, less entrainment of particulate phosphorus, and a source of hydration during dry conditions. This has resulted in much healthier and better performing marshes. Once a week, the STA team, which is composed of scientists, water managers, and resource managers, meet to discuss the flows into each flowway of each STA. Climate, weather, vegetation status, water depth, phosphorus loading rates, and other variables are considered on a flowway by flowway basis to determine how much flow to send. Stages and flows are monitored throughout the week to make any necessary changes in real time. This constant communication amongst the team helps prevent damage to the marsh and maximize performance. So let's go now through each of the STAs and their issues. So over the past 5 years, STA 1 East has received between 138,000 acre feet to 323,000 acre feet, with an increase in recent years due to construction activity in STA 1 West. Water year 2021 was the highest volume on record. This level of flow will stop once the STA 1 West Expansion 2 is online, which is expected in 2025. Inflow TP concentrations ranged from 93 to 266 parts per billion, which is a flow weighted mean, while outflow ranged from 18 to 47 parts per billion. Prior to water year 2021, inflow and outflow concentrations had been declining. Construction in the Western Flowway, which is highlighted in red here, plus the additional water from STA 1 West construction has resulted in high phosphorus loading rates to the eastern and central flow paths and causing declining performance. Once these projects are complete, it is expected performance will improve and QBEL will be achieved. To prove this potential thought, last week, the Eastern Flowway had an outflow TP concentration of 9 parts per billion for a 7-day average and 8 parts per billion for a 20-day average. So it is possible to achieve QBEL in this STA. In STA 1 West, over the past 5 years, inflow ranged from 109,000 acre feet to 195,000 acre feet. Inflow TP concentrations ranged from 136 to 254 parts per billion, and outflow ranged from 24 to 40 parts per billion. Much of this STA has been what we call online with restrictions for construction activities, which means that flow has been limited. The expansion number 1, cells 6, 7, and 8 are now complete and flow is beginning. Construction of expansion 2 is underway and expected to be completed in 2025. Once these construction activities are complete and vegetation grow in has occurred, the STA is expected to achieve QBEL. Over the past 5 years in STA 2, it has received 247,000 acre feet to 445,000 acre feet of inflow. The TP concentration ranged from 81 to 158 parts per billion, while outflow ranged from 14 to 38 parts per billion. Flowways 1, 4, and 5 consistently have outflow TP concentrations near 13. The 28-day average has been 10, 11, and 9 parts per billion as of last week for the flowways. Flowways 2 and 3, which are in the red highlight, have not been performing as well, so refurbishments are underway. Once complete, it is expected that the STA will achieve QBEL. Over the past 5 years in STA 3-4, inflow volumes ranged between 311,000 acre feet to 631,000 acre feet, which is the highest of all of the STAs. Inflow TP concentrations ranged from 61 to 128 parts per billion, which is the lowest of all of the STAs. Outflow TP concentrations has ranged from 11 to 13 parts per billion, which means we are achieving QBEL. The A1 FEB has benefited STA 3-4 by reducing peak flows and reducing inflow TP concentrations. However, even with the FEB in place, the many years of high inflow volumes and deep water conditions in the front end has resulted in vegetation stress and die-off. Refurbishments are underway in the eastern flowway, which is the red highlighted area, to restore the vegetation. Similar efforts will be needed in the central flowway in the future to remediate vegetation damage. Over the past 5 years in STA 5-6, inflow volumes have ranged from 118,000 acre feet to 217,000 acre feet, which is small for its size. The basin runoff tends to be flashy, resulting in dry out conditions, which is bad for STA performance. The C139 FEB is under construction and will assist in STA hydration. And in addition, a connection to Lake Okeechobee for supplemental water is being planned. Inflow TP concentrations range from 161 to 281 parts per billion, which is the highest inflow concentration of all of the STAs. Outflow concentrations ranged from 18 to 80 parts per billion. Earthwork in these cells here has been complete and vegetation grow-in is now currently underway. Once the C139 FEB is online, it is expected that the STA will achieve a QBEL. As of last week, the 28-day average for flow of outflow TP concentration was 12 for flowway 1, which is up here. So pretty impressive given all of the conditions that exist in STA 5-6. So overall, while inflow and outflow concentrations vary between STAs, performance is pretty consistent with an average removal rate of between 77 and 85% of TP, particulate phosphorus, soluble reactive phosphorus, and total inorganic nitrogen. Calcium, total nitrogen, and dissolved organic phosphorus are lower at 21 to 38% retained within the STAs. Based on period of record data starting in 1994 when the first STA was built and ending in 2017, Chimney found strong relationships between TP loading and removal with an R-square of 0.96. TN loading versus retained followed the same curve, but within a lower R-squared of 0.65. Both curves indicate that the STAs reach maximum removal rate, after which additional loading will not be as effectively removed. He also found a strong relationship between calcium loading and TP soluble reactive phosphorus and particulate phosphorus removal. However, there was no relationship with dissolved organic phosphorus. These relationships, among others, are being fully explored under the Restoration Strategy Science Plan. But before we get into the details of the science plan, I wanted to discuss the restoration strategies and refurbishment projects that the district has undertaken to improve STA performance. The first one was the L8 FEB. It is a below ground, approximately 900 acre reservoir, which provides 450,000 acre feet of storage. It provides flow attenuation for STA 1 East and 1 West and will assist in achieving QBEL. Construction of it was complete in 2017, and initial operations followed shortly thereafter. The L8 was assumed to provide no TP reduction as a conservative design assumption. However, it has provided TP reduction over water year 2019 to 2021 of about 14 metric tons. This helps reduce the TP concentrations to STA 1 East and 1 West. We are also investigating additional strategies to help increase TP retention within the FEB. For STA 1 East, we found that there was uneven topography within cells 5 and 6, which are highlighted in red, which impacted the hydraulics and the vegetation sustainability and treatment performance. We began earthwork back in the mid-2020, and the construction for the deadline for completion is the end of 2022, and we are on track for that. Vegetation and grow-in and stabilization will follow, and the refurbishment projects to refill remnant ditches in cell 6 for improved hydraulics was completed in December of 2020. To give you an idea of the scale of what that looks like, this is the cell 7 earthwork, which is nearing completion. And this is cell 5's earthwork with the vegetation is starting to grow in. So as you can see, it is quite a very large area that we are trying to refurbish. In STA 1 West, there's expansion 1, which is cell 6, 7, and 8, which is 4,300 acres that will add to the treatment of the flows going to 1 West to achieve QBEL. Construction was completed in 2018. We started flooding and optimizing the site in late 2020, and we are currently in flow-through operation. Refurbishment projects underway in the original STA 1 West cells to address topographic, hydrologic, and vegetation sustainable issues are ongoing as well, with completion date of 2022. One of those is the removal of this, what we call the dogleg berm, to make this an open area. So in cell 2A, this is the levee that is being removed right here. That corresponds to this part of the diagram here. And then in cell 3, there's also some more earthwork and a pump station construction. Expansion 2 is 1,600 acres and will also assist in achieving QBEL. Construction was started in 2020. Construction of treatment cells and 3 new pump stations are underway, and the deadline for completion is the end of 2022, with initial flooding and optimization to be completed by the end of 2024. In STA 2, cell 2, filling and regrading to improve hydraulics, vegetation conditions, and treatment performance started in October of 2020. The estimated completion for that is October 2022. And this involves installing cuts into cell 3's remnant farm roads to improve hydraulics. And that was started in 2021 and completed in March thereafter. This is cell 2 is offline for regrading, and you can see the leveling that was done within that cell here. And this is the filling and leveling of cell 2 to make the topography in there more level. The A1 FEB is a 15,000 acre above ground impoundment with 6,000 acres of acre feet of storage. It provides for peak flow attenuation and TP retention, which benefits STA 3.4 and STA 2. Construction was completed in 2018. It's been operational, let me back up. We started with the FEB and built it, and then found that there were some issues. And those issues were resolved in 2018. And for water year 2027 or 2017 to 2021, we've removed about 168 metric tons of phosphorus from the water before it goes into STA 3, 4, and 2. STA 3, 4 refurbishments, there were high flow velocities going into the marshes, and they were creating what we call short circuits, which you can see here. So the water flows from this way to this way, and this is where the vegetation was getting basically ripped out and creating short circuits. So it was the water was not getting a full treatment from the wetland. So in order to abate that, we put in what we call these energy dissipators, basically riprap, downstream of 17 different inflow culverts to reduce the velocity and to facilitate the sheet flow. This was paid for internally. The work started in January of 2020 and was completed in June of that year. The C139 FEB is an above ground impoundment, which will provide 11,000 acre feet of storage. Peak flow attenuation and TP reduction to STA 5.6 will be achieved. Construction was initiated in 2020 and is anticipated to be completed in 2023. In addition, we are looking for a Lake Okeechobee connection to provide supplemental water to STA 5.6 to help with reducing dryout. Phase 1 of that is expected to be completed in 2022. In addition, there was earthwork within STA 5.6 in this area. There were areas of high elevation that were not providing treatment, so that was leveled to get the topography level with the rest of the STA, improve the hydraulics, and provide vegetation sustainability. Construction was initiated in 2018. It was paid for with internal resources, and the construction was completed in May of 2022. Initial flooding and optimization period will be complete in 2025. Now, restoration strategies, science plan. I want to take a moment and acknowledge the water quality treatment technologies team. They are a small but mighty and dedicated team of ecologists, biologists, environmental scientists, biogeochemists, water quality and data QA experts, and engineers with decades of experience. Day in and day out, they think about STA science. That science is being conducted in the real world alongside the construction and refurbishment projects that we just talked about, the water management decisions that are made on a daily basis, and vegetation management activities that occur frequently within the STAs to improve performance. This presents many challenges, but the study's executions have been rigorous, scientifically valid, and comprehensive of the processes that occur within wetlands and affect performance. I couldn't be more proud of them. With that being said, let me tell you about all of their good work. So in 2013, a group of scientists from multiple agencies, including EPA, Department of Interior, Army Corps, and FDP, got together to create the science plan, along with representatives from the district. Specified in the restoration strategies, and was part of the science plan, and it was part of the permit and consent orders that a science plan be executed. The focus on understanding the processes that affect phosphorus removal in STAs at very low concentrations, the results of which will improve design, operation, and management of the STAs to reach QBEL. Each study is designed to address a relevant question for management and operation of the STAs. There's a complex set of oversight over the STAs. Starting with the outside agency tech reps, and the development of the science plan, which then led to specific studies in coordination with the tech reps and our internal leadership. The tech reps from outside the agency provide key oversight to the development of the science plan questions. Studies were designed to address the key questions and sub-questions. Each study was prioritized in importance, budgets were developed, and the science plan was published. Each study gets a detailed study plan developed by the study leads, which are the Water Quality Treatment Technology team. It is then reviewed by internal staff, the project management team, and lastly, the steering committee for approval. Once the study is implemented, it is subject to continual review through publication in the SFER, tech pubs, and journal publications, all of which are peer reviewed. Work is also presented at the long-term plan meeting and annual public meeting. So there's lots of review and oversight of the scientific work that we are doing. So the science plan is based on 6 key questions and 18 sub-questions. The first question regards the operation of flow equalization basins to alleviate peak stormwater flows, store stormwater runoff, and improve delivery downstream. The second question is about STAs to maximize P removal from the water column and reach QBEL. The third is to maintain vegetation communities to allow uptake of phosphorus and burial of phosphorus into the soil. The fourth is to understand and reduce the internal loading of phosphorus. The fifth is to understand the dynamics and interaction of chemical, physical, and biological aspects of phosphorus. And the last question is to evaluate the effects of fauna on phosphorus reduction and develop optimal ways to manage its cycle of P. We have completed to date 8 of the studies. The first was the operational guidance for FEBs and regional operation. Within that study, our major findings were that wave tests produce equations for flow, slope, and resistance to support STA operations. And from that, what was called an I model was developed for operational protocols. We also did what we call the Canal Study, and we found that canals can remove or export TP depending on the velocity that's running through there. So the FEBs are key to lowering the velocity of the water flowing through the canals so that they don't entrain particulate phosphorus and bring it into the STAs. One of the most popular ones is our PASTA study. From that, we found that muck removal, along with low inflow TP concentrations, can result in very low phosphorus concentrations. And for the past 13 years, the area that is where we studied PASTA has achieved the level of 13 for the past 13 years. We also did a study regarding water quality sampling techniques to determine the reliability of time-based autosamplers, grab samples versus flow-based autosamplers. And we learned that time-based and grabs are more reliable than the flow-based autosamplers, primarily due to interference with plant and animal contamination. Another study we did was to look at rooted floating aquatic vegetation to determine its ability to remove phosphorus within the STA complex. And what we found is that it was not as effective as SAB at removing phosphorus for a wide variety of reasons, including shading, which reduced the amount of photosynthesis occurring within the water column, which reduced the pH, which reduced the amount of calcium precipitation with phosphorus. So it was less effective, and we now discourage the growth of floating aquatic vegetation. We also did a very comprehensive study that we called PFlux, which basically looked at all of the ways that phosphorus cycles throughout a wetland. This was done in what we call a well-performing STA. to look at how phosphorus cycles throughout the well-performing STAs. We've also got another study that's currently ongoing called P Dynamics that is taking a look at the exact same parameters, only in flowways that are not as well performing, and they'll be compared once we get the results from that. Another one that we did was a water and P budget improvement, where there was a lot of effort put on improving the data going into how we assess the flows for our flow structures, and then doing a water budget to see how the water coming in from various sources, including rainfall, affects the water budget within the STA. And it provided us with a much more accurate assessment of the water and P budgets within specifically STA 3-4. Most recently completed is our Cattail Study, and it had a really good finding, and that is that water depths greater than 3 feet for more than 100 days can result in observable cattail stress. This is important for our water managers to know their duration of water that they can put into an STA for a given time. We found that depths from 3.4 to 1.4 feet resulted in leaf elongation. Essentially, the plants were reaching up to the sun to find any bit of sunlight, which caused them to be fairly weak. And we found that once the water levels came back down, those plants actually collapsed under their own weight. So these were very important findings for us for how to manage or not manage an STA. And we also found that there was reduced adult and juvenile cattail after the first 8 weeks of flooding. There are 11 studies currently underway with completion dates between 2022 and 2024. The last one, data integration, is actually 4 separate studies. In addition, there are 2 other studies in the early stages that we have yet to kick off. One is an advection study. We just got it through that DSP review process that I mentioned earlier, with the steering committee just approving it this week. And the other one is a landscape study where we're going to construct some flumes to understand flow levels through a landscape. All will be completed within the next within the next year or 2, except data integration, which will continue until 2024 to capture the results of all the studies that are ending in 2023. As part of our data integration study, we are constructing a pretty comprehensive model. It's actually 3 different types of models. There's a emergent aquatic vegetation and an SAV aquatic vegetation biogeochemical model that is being developed. You can see the conceptual design to your right that looks at all the different flows of phosphorus through the system and all the different forms and various factors that affect it. This will be linked to a CHASM model, a comprehensive aquatic system model, which is a 2D food web model. The reason that this is important is we have found from the faunal study that fish are actually really important components of the internal loading study variables. When they're doing their nesting and their feeding and whatnot, they kick up a lot of particulate from the soils and are contributing greatly to internal loading. So using that food web model linked to the biogeochemical model, we will be able to tease out which of these processes truly driving performance and P reduction within the water column, and that'll allow us to focus on those areas from a management perspective. All of this work has resulted in quite a bit of publications. Just within my internal staff, not including contractor publications, we've gotten 11 published journal articles since 2015. We've got 25 peer-reviewed tech pubs since 2018, and we are currently working on a special issue in ecological engineering of 32 papers between us and our consultants and contractors. So we're doing lots of good work. We're getting it out there into the public realm for review and evaluation. And it has been quite an interesting effort, especially this last one, pulling all of the aspects together. Basically, it's one big data integration type event. So I'm very excited to see the results of that, and that issue should be published next summer. And that's all I have. If there are any questions.
Thank you, Cassandra. That was wonderfully comprehensive and very, very useful, the level of information provided. I will now remind committee members that if you go ahead and raise your hands, I can call on you for questions. I'll go ahead and start with Ehab.
Well, thank you for the presentation. That was very informative. I just have a simple question regarding the, the reservoirs that you mentioned. Some of them are above ground and some are below ground. Have all these studies showed their performance and how it's being sustained over time? Do they decline over time and they require some sort of maintenance? And if so, like how frequent would they need to be maintained to keep their capacity?
Yeah, to date, we have not seen any decline in the performance. So the L8 is a very deep reservoir. It used to be a rock mine, and it's fairly new, so we don't really have a lot of trend data for over time. But that one, as I mentioned, was not really expected to reduce phosphorus because it was an old rock mine. Turns out that it actually can, and has improved over the past couple of years of data that we do have. STA1, the A1 FEB is a shallow reservoir. It's essentially operates at 4 feet and very similar to an STA. Its performance, for lack of a better word, over the past several years has been fantastic. The water coming out of that there's near Cubell. As I said, it's fairly new, so we don't have a long-term data set to say whether it's declining or increasing in performance. But to date, the water quality has been fantastic coming out of there.
Okay, Charlie.
Good morning, and thanks for a great presentation. There was a lot of detail and it was very informative, so I really appreciate that. So I actually had 2 questions, but I'll just start one and then I'll wait until see if other people have questions. But my first question deals with calcium, and I've heard sort of anecdotal information over the years about the importance of calcium, and I've seen long-term data, I mean really long-term data that has shown a long-term decrease in the calcium inputs to these systems. So I was wondering, could you talk a little bit more about that? And you know, I understand that there's a lot of calcium within the geological materials, but there must be variability in terms of calcium content of waters that are coming into these STAs. And will you use this information on calcium to try to influence the operation of these systems? Or I just wonder if there's any thoughts on that.
Yeah, so that's a really great question. Thank you. Calcium is turning to be an important process for phosphorus removal within the STAs. And as you mentioned, there is a lot of calcium in the system because of the lime rock that we have throughout. So most of the water that each of the STAs receive is from the watershed, and therefore pretty high concentration of calcium. The lake water actually does not have as much calcium in it. So it as a source water would bring in less calcium. That is also something we have not yet addressed, but have started talking about addressing within the science plan, is looking at the different source waters and how that may impact. STA performance. So that is a question unanswered so far, but it is definitely on our to-do list. And it will have direct ramifications for how we manage the STAs, how much lake water we take in versus runoff.
Okay, great. I'll look forward to hearing what you come up with and more on the role of calcium. So thank you.
Sure.
Charlie, I'll come back to you, but I'll go to EHAB first and then I'll come back.
Okay, I'm sorry, one more question. You mentioned there is a comprehensive water quality model that in your probably the one before last slide that you mentioned, and I didn't get the name of that model, but can you elaborate a little bit on how the role of that model and how it will be used in the STA management? Is it going to be integral as part of the combined with the monitoring that will be used to manage the STAs?
So we don't know the results of that model yet. It's still being developed and in construction. What I envision to happen is that we will learn some of the processes that are more important than others in driving the performance of each of the STAs. And knowing that, we will then take that information to our managers to help guide them with decisions. It is possible that for example, the funnel being an important process for internal loading, our managers may decide that we need to do some type of fishing, have folks come in and do some fishing to remove some of the fish biomass out of there and reduce the amount of influx. But these are more one-off type of recommendations. It will not be like an ongoing operational management type of model where we can turn knobs and tweak things to see how things are going and then inform back to management. It's more of a overall arching results of the model and where we see points that can be managed, and then inform the managers of those points and how we can take advantage of that.
Thank you.
Okay, Charlie, we get your second question and then we'll go to Alan.
Okay, great. Well, my other question concerned if you would be willing to speculate. I mean, you've got a lot going on and it's really exciting to see this and it'll be very interesting to see how it plays out. But given the timing of your activities, one of the things that we've been concerned about over the last few reports is that there hasn't been really any consistent decreases in the effluent phosphorus concentration. And so I think we've talked about that in past reports. So I guess given the activities, we would expect to start to see some of the concentrations coming down. And so would you be willing to speculate, which of the STAs we might be able to see the impacts of these activities, sooner than others?
I don't know if I can speculate on that. I definitely can say that some of the projects are going to come online first. And I would expect that those would be the ones that will start to show results a little sooner. For example, the STA 1 West expansion is now online and we are having flow through. So hopefully within the next 6 months or so, we can start seeing some trend data for STA 1 West, because that one is complete and the refurbishments in that one will be complete as well soon. Some of the other ones, for example, STA 3-4 that are vegetation refurbishments, those I expect will respond quickly. Those are a little easier to implement than a bulldozer running through your STA. We're just planting some plants. So hopefully those will help STA 3-4 in those particular flowways achieve QBEL a little bit more quickly, because it is, to use a euphemism, low-hanging fruit. But yeah, I expect that all of them will achieve QBEL, but I do think that STA 1 West, given its current status, and STA 3-4 will probably be our first two.
Okay, very good. Thank you.
Mm-hmm. Okay, Alan, and then Deirdre will be following Alan.
Thank you. Great presentation, Cassandra. I really appreciate the information. I too have two questions. So Denise, you can send me to the back of the queue if you want to after the first one. I noticed in your data for STA 1 East, if I remember correctly, that from 2017 to 2018, the TP concentrations increased dramatically, but the actual flow volume stayed steady. So you couldn't attribute it necessarily to greater flows coming in with more concentration. So I'm curious what might have accounted for that and whether there's anything to be learned from that change over that short time period. I realize that, you know, with the changes over the last few years, this may be a moot point, but I'm still curious about that data spike.
No, that's a really good question. And I don't know the answer to as to what was going on. There may have been a storm event of some sort. But I'm just spitballing here. I don't know why that one spiked up, but if you'll see in 2019, it's still pretty elevated. So that's something I can go back to my team and see if they have an explanation for that, and I can get back to you on it.
I appreciate it. It's not so much to answer that as much as whether there's anything to be learned from it in terms of future design or management strategies. And that's really where I'm getting at.
Gotcha. Yeah, no, I think it's important to find out why, because that would help for the management. If it was a one-off type of storm event type of thing, that means one thing, or if this was more endemic to some activity that was going on in the watershed at that time that I just don't know about, that would result in a different management tactic. So let me ponder that one and I'll get back to you.
Thank you.
Jen?
Yeah, so I think we can address that a little bit, and I might call on Jose because I believe that we have looked into that spike because, of course, of the same things that you mentioned. We also were concerned and wanted to look for lessons to be learned. So and you're talking about the spike in water year 2018, right?
Mm-hmm.
Yeah, so I wanted to make sure I was addressing the right thing.
Appreciate that.
So water year 2018 reflects Hurricane Irma. And so water management activities that had to do with flooding and mitigating the flooding impacts of the rainfall we received across the entire area during Hurricane Irma required us to do some additional water management activities that are a little bit different from our regular operations. And so some of the inflow spike that you see in these STAs have to do with those water management activities upstream and within the basins that are served by those stormwater treatment areas. And so it's a reflection of some of that. So you had areas that normally aren't inundated that are, and then high volumes of runoff, and we were having to manage water. And I'm going to turn to Jose Otero and ask him if he has maybe some more specificity that he could discuss, because I wasn't actually with the district when we were doing those water management activities. And so Jose might be able to provide a little bit more clarity on it.
Sure, Jen, I can provide a little bit more. This is Jose Otero. Water year 2018 had two significant events. June was a month of record rains. So we started off the wet season with record rainfall. And September was Hurricane Irma. And you'll see in all of the STAs for water 18, there's a spike in the flow volume and a spike in the inflow concentration, except no spike in the inflow or the outflow concentration for STA 3-4. STA 3-4 has been resilient, has had the benefit of the attenuation provided by A1 FEB. That's something that's our star STA, but it does have the benefit of the A1 FEB as a large buffer of high flows. And we know that very high flows result in even higher inflow concentrations. So that signature that you'll see in all of the STAs in water year 2018 is those historic events that happened at the beginning and at the end of that wet season of water year 2018.
Jose, I appreciate that. I may be misremembering this, and I don't know if Cassandra can actually bring up that slide, but I thought that the flow volumes for 2018 were actually very similar to 2017 in her graph. And that's why I was asking this question. And so obviously this is, I assume it's annualized, but it could be that, I can't remember what slide it was, Cassandra. But it was when you were showing the performance on STA 1 East.
Yeah, I think it's slide 4. And you're right, the volumes for
Yeah.
1 East were similar, but the concentrations are significantly more. And I think it has to do with how we managed the water differently from how we normally manage the water. So let us take that back, and we can provide a more specific example of those differences that might have that we're attributing some of those increased concentrations. I don't want to get it wrong here and have everybody
Sure.
understanding the information incorrectly. I'd rather be more precise.
And I didn't mean to get us off on this track. I was curious. So thanks, Jen. Thanks, Jose. Appreciate you following up with that.
Alan, I will go to Deirdre, who's been waiting patiently, and then I'll boomerang back to you.
Thank you.
Got to unmute myself. Thank you, Cassandra, for a really informative presentation. I'm really, really new to this committee, so that really helped me a lot. Kept me looking back at my acronym cheat sheet. So I just want to say, sometimes it seemed like a foreign language, but anyway. I had a question, and this is really just for clarification and just trying to understand the whole system. But one of your slides, you mentioned that there was a 450 or 400,000 acres of underground treatment, and that actually in the slide it said 45,000. So I was curious, which it was. And if you could talk more about what this underground treatment is, and I hope I'm not getting that wrong.
So that is our L8 FEB. It is 45,000 acre feet. It's not underground. It's a deep reservoir. So
deep reservoir.
Yeah, it's a really deep reservoir. It's a 900 acre reservoir that goes down to almost 50 feet in some areas. So that's why we get 45,000 acre feet. It's an old rock quarry, which is why it's so deep there. And there was no expected treatment capacity for the FEB when we designed it. However, it has proven over the past couple of years that it is capable of reducing phosphorus. Most likely it is coming from particulate settling out of the water. One of my staff has done a really comprehensive study of the inflow phosphorus into the FEB is very particulate heavy, especially during high flow. And then when the water comes out, the majority of the phosphorus is in dissolved form and in much lower concentration. So it's primarily the physical settling out into the FEB of the that is achieving the phosphorus removal.
Okay, thank you.
Mm-hmm.
Thanks, Deirdre. Alan, we'll go to you, and then we have Bill and Phil.
Thank you. Cassandra, I seem to recall reading somewhere, there's a lot of materials that we've been digesting about the thought of chemical inactivation not being effective or not being necessary in the STAs. Perhaps that's because you feel like you're going to meet the QBEL with the current structures and the current modifications you're making. But I'm wondering if that is being held in reserve as a possibility. I assume it's being studied as one of those many studies that you're undertaking right now. So I'm curious where you're at with that.
Thank you for that question. It's a really good question. So there has been a lot of effort looking at chemical addition for phosphorus removal within the Everglades, dating back to before the STAs were actually built. And one of the reasons why that was shied away from was the potential for harm to the Everglades. For example, alum containing sulfate was of concern to the Everglades with some mercury methylation potentials. So there was a lot of worry that adding the chemicals to the STAs would result in negative effects downstream. So we held off on that. The other thing is scale. As you may have seen from some of those pictures, we're talking about large areas, and it is just not cost effective to add, tons and tons of chemicals to our STAs to help with the phosphorus removal. I think one of my staff did a calculation and equated it to the amount of rail cars that would be needed to bring in the chemicals to accomplish this. And it was like a 200-mile long train. It was just not feasible. That being said, we are considering it in a very small scope. So as I mentioned, the L8 FEB is very deep. It is a rock quarry, and it is at the head of the system for STA 1 East and 1 West. And we are currently looking at that as a potential for receiving some form of a coagulant. We don't know which one yet. But it's in discussion and then one of the things that, again, we need to worry about is what does the resulting water quality look like to make sure that we aren't causing harm by introducing a chemical that may be, chloride might harm the plants, or sulfate might cause mercury methylation. So anyway, we're being very cautious, but it is on the table.
Thank you. I would certainly caution you to stay away from alum, but certainly phosphlock, lanthanum, bentonite would be much less toxic in those systems. And rather than trying to surface apply it across the huge swath of STA, if you did it in the inflows or outflows in those STAs that are underperforming in a very localized, strategic, targeted fashion, I could see that they would have potential value. Now I'm biased since I do that kind of work, but I'm glad you're examining it, and I would suggest that you keep it on the table, if nothing else, in your back pocket.
Yep, definitely.
Thanks, Alan. Bill?
Thank you, Denise, and thank you, Cassandra. I too have 3 questions. I don't think I'll get them all in, but I want to start with one related to the data integration modeling effort, which I know is not going to be done to 2024, but I was trying to make sure I understood the scope of that. That looks like that the integration is really across different processes within an STA, as opposed to a integration across STAs in a sort of a larger networked operational model that you might be using to how do we operate the whole system across all of the STAs. And so I guess I'm just trying to get clarity on if that's kind of an STA specific modeling effort, and whether there's any intent to do more of a networked system level operational sort of integration model.
So your assessment is correct. It is an STA specific model. And we would love to be able to combine them at some point in the future, where each of the STAs, like you said, would be networked together. That is a pretty large undertaking. And if we did such a thing, it might not be available for quite a few years, but it is a potential. But you are correct. These models are very STA specific.
So do I get a second one, or do I go to the back of the line?
No, you can ask your second one, then I'll go to Phil, and then I'll come back to you.
Okay, so the second one, I wonder, it's sort of the opposite of Alan's question. It's sort of like, and Jose spoke to it a little bit. I mean, STA 3.4 has been the star, and he mentioned it benefits from the large A1 FEB. And so I guess, what is it from, what can you attribute that star performance to? And to what extent has that informed your other efforts? I presume that's why we're looking at the L8 FEB and the C139 FEB and some other FEBs, but are you going to be able to get to the same sort of scale of FEB to treatment to load sort of relationship you've seen there? And so anyway, just a little bit more, and it seemed like that PASTA study most likely was done in that area as well, just given the performance statistics you talked about. So maybe just talk a little bit more about what is working so well in STA 5.6 and how that's informed, or what else could be learned from that for the other STAs.
Sure. So the A1 FEB has essentially functioned as an STA, and it's vegetated, it's shallow, and so the water quality that's coming out of the A1 is really good. It's in the teens to low 20s, which means that the loading going into STA 3.4 is quite low. So it essentially doesn't have the heavy lift that, for example, STA 1 East and 1 West do. The concentrations are a lot lower. And so that is definitely contributing to why STA 3.4 has been doing such a stellar job at reducing phosphorus. You're right, the PASTA study was done in 3.4. It's a small area. It originally started off as some mesocosm studies that were done down there, where they removed the muck down to the lime rock in that small section. And because of that connection with the lime rock, the water quality has been really good and has maintained the 13 or below parts per thousand for the past decade or so. So that is independent of the FEB as to why that is doing so well. To your question about 5.6, yes, the C139 FEB is also going to be a shallow FEB, so should operate in a very similar manner to the A1 with regard to performance and reducing phosphorus loading going into 5.6. The issue with that basin is that it's very flashy. And so the quantity of water going into both the FEB and into the STA is challenged, which is why we're looking at that other source of potentially linking it up to the lake in order to maintain that hydration. But yeah, the C139 is expected to help keep the hydration in 5.6 and also provide a little bit of phosphorus removal so that the loading rate into 5.6 is lower and more similar to what we're getting with 3.4.
So just quick following up, is that planned connection to Lake Okeechobee for 5.6 linked to the Eaa reservoir and the Lake Okeechobee water coming that way, or is it independent, or could be operated independently of that?
Going to defer to Jen on how that would be operated.
It's independent.
Okay, so that will fix the flashiness of 5.6 independently of the Eaa reservoir connection. Okay, thank you.
Yeah, in conjunction with the FEB.
Yeah.
So the C139 FEB is another key project to help with the rewetting of.
Yeah, so you have a buffer there.
5.6.
Yeah, you have that buffer there. Very good. Thank you.
That was very wily, Bill, sneaking in a follow-up question. We have just a minute left in the formal time. Cassandra, can you stay on? Are you okay for a couple more minutes so we can get to the final questions?
I'm totally fine with doing that.
Okay, thank you very much. Phil, you're up, and then we'll go back to Bill. Phil, you're muted.
Thank you. So thank you very much for a very informative, lots of details. It strikes me that from the perspective of sustainability of the STAs, the issue of internal loading is going to become more and more and more important. And so is the detail in the food web model sufficient to resolve species-specific fish behavior? I mean, where I am, catfish do nasty things to lake turbidity, much more so than other species. I don't know if you have crayfish, or if the water's too deep for them, but I can imagine between the fauna and between flow and possibly wind seiches. There are a variety of mechanisms that could contribute to internal loading. And I'm wondering sort of at the level of the detail, you can actually keep track of those things.
So that's a really good question. We do have our final study focused on different species, and not only in their activity from building nests and feeding and whatnot, but also from excretion. And while what we decided to do, we didn't go to a species level, but we went to a size level. So the larger fish versus the smaller fish. And so the larger fish are more prone to cause internal loading through their nest building and their changing of the bottom. Whereas the smaller fish actually contribute significantly through excretion, much more so than the larger fish. So to your question, there is some level of quantity of known, like this type of fish is going to do X and this type of fish is going to do Y, but we don't have it down to the species. But we have the common, like tilapia is a big one that we have a lot of tilapia in our STAs. And so, from that we can, if we're trying to solve the particulates, we know that maybe the tilapia should be the focus, the larger fish should be the focus of any efforts versus the small guys.
Thank you.
Mm-hmm.
All right, Bill, you're in the red zone. Take us over the goal line.
No, I'm good. I'm good.
All right. Yeah, excellent job. We were going to take a break now. We'll be go attend to your blood sugar, take a stretch, and we will be back at 11:40. Thank you. Thanks. Welcome back, everyone. Hope everyone got a chance to stretch. We are going to start back on time now with a discussion about EAA reservoir STAs. And we're going to have a presentation by Ken Bradshaw of the Corps. So Ken, the floor is yours.
Thank you, Denise. So what I'm going to give here this afternoon, or this morning still, I guess, is a kind of high level overview of the SEP EAA phase and the water quality overview that we went through kind of during the planning process. So you can go to the next slide, Sarah. So as I said, the purpose is an overview of the water quality analysis for the Everglades Everglades agricultural area as part of the SEP project. Go ahead. So the SEP project, the overall goal of the SEP project is to improve the quantity, quality, timing, and distribution of water flows into the Central Everglades through Water Conservation Area 3 and Everglades National Park. And the purpose of the SEP EAA phase and the components of the EAA phase are the purpose being to capture, store, and treat water prior to sending it south. So to do that, what was proposed in the EAA phase as of, 2018 was a 240,000 acre foot reservoir that's adjacent to the A1 FEB. You can see there in blue in the photo, it says A2 reservoir, and a 6,500 acre STA that would take the water from the A2 reservoir and treat it through the STA prior to sending it south. And this would, the EA or the reservoir and A2 STA would integrate operations of the existing A1 flow equalization basin and allow more water to be sent south from Lake Okeechobee. So as of right now, the reservoir is under design, and we issued the first construction contract for some of the canals back in September. And the STA is also under construction by the South Florida Water Management District. And the overall purpose being to support increasing the amount of water moving south up to 370,000 acre feet more water on an average annual basis, whereas the original SEP proposed 210,000 acre feet. The next slide. So this is just a brief history of sort of the EAA planning process. EAA was originally approved under SEP as in WRDA 2016 with what's called the A2 flow equalization basin. In March of 2018, South Florida Water Management District submitted what they call a 203 study to the Assistant Secretary of the Army of Civil Works, and that was proposing a reservoir and an STA in the A2 area in place of the flow equalization basin. And then in WRDA 2018, the 203 study was approved and construction was authorized pending completion of a report that we call a 1308 or a 1308B report that it was intended to address concerns that were identified during the review of that 203 study. And then after was in WRDA 2020, the Corps had completed a final EIS and a TEAS report, and Congress placed the EAA reservoir back under SEP authorization, essentially resulting in a fourth phase of SEP. So 4 phases being SEP EAA, SEP North, SEP South, and what's called SEP New Water. And then in April 2021, the Corps and the South Florida Water Management District issued a project partnership agreement to begin construction of the EAA phases. Next slide. So I wanted to briefly cover a couple of the agenda items that were presented to us, and just to give you some of the background information of some of the water quality analysis that went on during the planning process. So the DMSTA, or the Dynamic Model for Stormwater Treatment Areas, version 2, developed by Drs. Walker and Cadlick in 2005, was the primary phosphorus model used to simulate phosphorus treatment through the SEP EAA project. That model assumed that the model used flow that was brought in from other regional simulation models, in this case, the RSMBN, or the Basin Simulation Model. And that was the same model used for restoration strategies, the DMSTA and RSMBN. The lake phosphorus assumptions were that we used the period of record from 2000 to 2009 monthly averages from S351 and S354. Those are the structures on the lake where the water will be sent south. The STA had a duty cycle of 95%, meaning that 5% of the time the STA was offline for maintenance and recovery. And then the calibration set that was used did not assume restoration strategies improvements yet. So it was pre-restoration strategies and implementation. The model also incorporated resting periods that allowed vegetation rejuvenation and expansion. And finally, the annual predicted TP concentrations that are lower than 12, anything predicted lower than 12 parts per billion by the model, were rounded up to 12 parts per billion. So during the review of the Packer and the review of the 2020 draft EIS, there were some concerns identified that with the DMSTA model that the calibration was old and dated. Some discussion that Lake Okeechobee total phosphorus could be higher than what was assumed from 2000 to 2009. You know, that could be based on weather events or extreme events like hurricanes that stir up the lake. And then due to these concerns, that led to concerns that there were risks that maybe restoration strategies would not meet the QBEL in time based on the modeling that was done, and concerns that things like the water quality based effluent that Dan Scheidt discussed and the TP rule sites could be impacted. And so there were some uncertainties identified through the modeling effort as we went through the different planning stages. Next slide. So to answer the question of what was done to get at those uncertainties and to look at the review comments, there was a verification or a validation of DMSTA done by Dr. Walker and DOI that essentially looked at 5 more years of data after the 2005 calibration period and the measured phosphorus in STA 3-4, and it basically showed that the model predictions were consistent with measured total phosphorus in that STA, and that's important because that STA has similar soils that are into the A2 STA, and the model essentially over predicted outflow loads in recent years. Therefore, it was determined it was conservative for designing projects in the Central Basin. And so there was a DOI letter of support in the 2020 EIS to document that. The model was also prior to the 2014 effort. It was certified for use by the Corps of Engineers through their hydrology and coastal community of practice. And then through the effort of model, validation and planning, USACE determined that any further calibration of the model wouldn't reduce or could expand the uncertainty. And so it was decided that, a better way to look at uncertainty and deal with uncertainty is through the Corps' adaptive management and monitoring process. There were also concerns, the way the concerns of the risk of restoration strategies not meeting the QBEL. At the time, the STAs were showing progress to meeting the QBEL, but the Corps was still concerned that there be reduced benefits or impact to water quality if it didn't. So that was kind of the background behind the uncertainty that was identified for the QBEL. And then the TP rule sites downstream that Dan described, there was also uncertainty identified about meeting or not impacting those TP rule sites. And essentially that was because there were limitations on the predictive tools that could be used to do a quantitative analysis There was some uncertainty in how the system would respond to new water, particularly because we don't have a lot of historical data that shows within the Everglades system how, redistribution of flows and more flows will impact those TP rule stations. So with all that, there are going to be, I guess, requirements for the new STAs to meet, I guess, an NPDES defined water quality limit. Whether or not that's the QBEL that exists for the other STAs is to be determined. That'll happen during the permitting process. And then looking at the settlement agreement sites where there was uncertainty identified going into the park, essentially the way that we have to deal with that is to look at how that calculation is done as new components are added on and new flows are brought into the system. So that'll be an ongoing effort that's evaluated by the technical oversight committee that's assigned under Appendix A. The next slide. So another item or another area of concern that was identified during the planning process was through the Miccosukee tribe of Florida. And they had concerns because their lands are within Water Conservation Area 3A, and they thought that the upstream air, the water quality from the upstream area could impact their water quality standards. And as Dan mentioned in his presentation, they have an approved EPA standard of 10 parts per billion, and they were worried about additional water from the A2 STA. If it did not meet the QBEL, it could impact their water quality standards. So during the planning process, we had a government-to-government meeting with the tribe, and we kind of went through, the purpose of the project and how water would be distributed, redistributed to the different areas, and that the expectation from us and based on the modeling that we have at the time was that we would meet the water quality based effluent limit. And therefore, if we thought of meeting 10 at the inflow to Water Conservation Area 3A would satisfy their water quality standards. The outcome of that meeting was that they requested a couple of monitoring stations at the northern boundary of the North Newgrass area just to verify or validate that water quality that's coming in. And so through coordination with the Southwater Water Management District, EPA, the tribe, and the Corps, the two station locations and the constituents to be monitored were identified, and they were included in the district's A2STA 404 permit. But the bottom line is that we expect that the 13 parts per billion annual flow weighted mean leaving the STAs will meet the tribe's standard of 10 parts per billion. And then in the EIS, there is actually, I guess, language that points to the fact that if measures or if water quality isn't met, then we would go back and look at additional measures to implement to make that happen. Next slide. Okay, so this slide kind of gets at what I was just talking about in the first panel discussion of what are the water quality implications to the EAA phase based on the water quality or the authorizations we have for water quality under CERP. So this is a list of implications that are within the different planning documents and agreements. So essentially, no EAA water can be directed to state facilities until all restoration strategies are complete and all the requirements of the NPDES, the Everglades Forever Act, and the two consent orders requirements are met. The new water from the project is also dependent on excess capacity of those STAs within the system. So that's one of the reasons why we have to depend on the state to meet restoration strategies and those water quality standards first. If there's a period in time where the EAA is operable, but the water quality hasn't been demonstrated yet, the EAA can be operated to flow only the amount of water that's can be treated by the STA, the A2 STA only, to meet applicable water quality standards and any standards necessary to meet Everglades restoration standards. At the time of the final EIS, we did not have a final or a draft final project operating manual, and so that'll be under development during the PED phase, or the pre-construction engineering design phase. And then, oops, sorry, my computer just fell. And then finally, as Ms. Reynolds mentioned earlier, a lot of this is really impacting not so much the construction, but the operations and the cost share of the operations of the STA and the reservoir. So the final, one of the final determinations was that the cost share would be determined of the amount of new water, and it will be somewhere between 0 and 50%, federal, non-federal. Construction costs for any of the non-water quality construction costs and any of the non-water quality treatments for O&M are all cost shared 50-50. And then the Corps and the non-federal sponsor of the district were presented with a path forward on how to determine the cost share requirement, and that work is currently ongoing. So with that, next slide, that's my high-level overview of the planning process and some of the water quality items that we address during the planning process and as we go in through construction. I can take any questions.
Thanks very much, Ken. Committee members, if you want to raise your hand for questions. Okay, Eaa, go ahead.
Just a quick question about the model that you all are using for the Walker and Cadillac, the DMSTA model. Are there any plans down the road that you will coordinate the utility of that model with some of the other tools that was mentioned in the previous presentation, that biogeochemical model that is being planned to be also feeding a food web, the chasm food web model? I'm just trying to understand the big picture of how all the predictive tools are going to be coordinated and delineated to inform the decision-making process in general. Are there any plans for such coordination down the road?
To my understanding, the Corps is not taking the lead on any of that coordination for any of the modeling updates, but there may be some coordination by some of the other cooperating agencies to do so, but I don't know exactly, what that coordination is thus far.
Okay. Bill?
So thank you, Denise, and thank you, Ken, and very nicely done. And thank you for addressing the sort of posed questions pretty directly. So really appreciate that. I have, and you can orchestrate this however you want, Denise. I have 2 or 3 that are mostly sort of follow-up clarifications of things that Ken mentioned. So I guess starting with the cost share piece. So this project has both the reservoir and the STA, and as you mentioned, the new water, the water quality cost share will be based on how much of it's new water. So and that's has to meet all the WQBL before that part of the cost share will be provided. Is the cost share for the reservoir separate? Is that considered quantity versus quality, or is the whole project sort of the cost share on hold until the water quality aspects are clearer? Does that make sense?
Yes, more or less. Yeah. So I think the process to determine what the cost share will be was outlined in our decision documents. And so it's, you know, some of the process deals with just getting an understanding of what the water quality is and, you know, what the required treatment is. And again, we haven't finished that process. We're going through it now. But I think overall, and Jen, you can correct me if I'm wrong, the EAA reservoir and STA are not cost shared separately. It's all one project, I think. Is that right?
Yeah, not only are they not cost shared separately as a project, but the entire program is cost shared. And so the entire program, the entire CERP program is cost shared 50-50. And so each of the projects, whether it's Indian River Lagoon South or the EAA reservoir or anything in between, they are all compiled on one cost share balance ledger. And we programmatically cost share the entire CERP program, which is why the Water Management District constructs some features and the Corps constructs others, and we don't have to split the cost of each of those 50-50 by individual components or items or projects.
So just
And for the EAA reservoir and STA, all of the construction has already been agreed upon and cost shared. And so the only policy issue that we have outstanding between the agencies is the cost share on the operations.
Okay, great. Thank you. That helps. Am I still up, Denise, for another one?
You are.
So Dan, see if I can find my notes here. So the sounds like the final water quality restrictions for the EAA water coming out of the EAA reservoir STA are still being determined through the permitting process. Through the sort of legal process, but the design and permitting was based on the existing WQ bell. Is that a correct interpretation of what you said?
Yeah, I believe the design of the STAs was based on the existing Q-bell. But my understanding is that STA will have its own NPDES permit, and the discharge limits will be established in that permit.
So they could be different than the other ones, but likely be very similar, I would presume, but to be determined.
Presumably, but again, it would have to be decided at that time, and you know, I don't think the district needs that permit until it comes time to operate it. So right now, it's still you know, an outstanding item to do.
And I guess my final question, I think you answered it well, was in the interim until restoration strategies has been achieved, which, you know, isn't due till 2026, 2027, that as this EA reservoir and STA get built, if my understanding is under the Corps' secretary's restrictions, if it can be operated at a level that water coming through it and out of the SDA meet the current WQ bell, could be operated at whatever level of flow that is. And then that water theoretically could be used either for irrigation or put into the system, since it'd be new water that meets the WQ bell. And so it's basically just in the short term restricts the potential amount of water that could flow through it based on the quality coming out the end. Is that an interpretation of kind of the current restrictions, you know, I mean, once it comes online?
Yeah, I guess ultimately the restrictions limit the amount of flow that can go through the system. You know, it's going to be less than what was approved through the full authorized project, right?
Right. Yeah.
And so, you know, what the uses are, I can't so much speak to. You know, whether it's irrigation or just restoration water. But that's essentially it. The EAA can operate to treat just the amount of water that treat the water quality standards.
Thank you. Yeah, thank you very much. And good, nicely done. Thank you very much.
Denise, if you don't mind, I'd just like to clarify one small thing. So from our perspective, the reservoir is going to be constructed and won't even come online until after we've met the QBEL. And so we're really not concerned about this issue because we are going to comply with all of our permits. And we have every confidence that, that Cassandra already presented, that we've figured out how to meet the QBEL, and we are replicating that certainty across all of our STAs, including the STA associated with the Eaa reservoir that we have under construction now. So we're using all of those lessons learned. And the timeline of the construction of the reservoir comes after restoration strategies projects are complete and we're meeting the QBEL.
Thanks, Jennifer. That's really helpful. Any other questions from the committee? If not, I would say you are all contributing to making me look like a genius facilitator at keeping us on time. So I'm very appreciative of that. I think if there are no further questions, Bill, are you good? Okay, great. We'll go ahead and move on to the panel. And before we do that, I'll just remind you again that what we really want, or what we hope for as a committee, is to determine where we can be most useful and helpful in moving the effort forward. And I think the next session is really going to help us do that. It is a panel discussion about science advances and needs. We have three panelists. We have Jennifer Reynolds from the South Florida Water Management District, Ed Smith from Florida DEP, and Bill Walker. We have given them each up to 7 or 8 minutes for opening remarks. You can use all of that if you wish or not. And then we'll go on to taking questions from the committee. So I will let Jennifer kick us off.
Well, luckily, I just was able to give you some of what was primarily my opening remarks at the end of the last session. And so what we are really looking forward to is the committee's input on any of the science matters that we have. Some of the discussion earlier about chemical treatment, for example, was, I think, really helpful to understand if the committee has some recommendations or some areas for further investigation that dovetail with our existing science plan and with the way that we have forward with our STAs. And I just wanted to sort of highlight that, again, we feel very confident that we have decades worth of science and analysis and assessment that we have put into the stormwater treatment areas. There is no one in the country that is implementing these types of stormwater treatment areas on the scale that we are. And so we really see our scientists as the cutting edge of this innovation and delivering clean water to the Everglades. And so anything that the committee can offer in your review of our science in that area would be greatly helpful. And we look forward to that. But otherwise, we are moving expeditiously forward in taking the lessons that we've learned, implementing those through the construction that we have ongoing, which is basically in every single STA we have. We are taking all of those lessons learned and implementing projects in order to optimize the performance of every one of those STAs. We're replicating it in our new construction, both with the C-139 flow equalization basin and the Eaa stormwater treatment area that's associated with the reservoir. And with that, I will turn it over to the other panelists to give some opening remarks. Thanks.
Yeah, and Jennifer, I would just say anywhere else in the world, what's going on would be extraordinary, right? So it's a lot of fun to work on science, on pushing it past extraordinary. So Ed, you have the floor.
Thank Thank you, Denise. I think just echoing Jennifer Reynolds' comments, it is, as someone who gets to participate in the tech rep meetings regarding restoration strategies, it is quite amazing to see the amount of information that the South Florida Water Management District is able to generate and the outcome of those studies and the way that they partner with not only DEP, but other scientific communities, Department of Interior, the EPA, all the different groups to share the information and really, expand upon what they're learning with everything. It really exemplifies how they're able to take all of these things that they're learning and implement it into further STA improvements. And, really, I can't speak more than what Cassandra presented earlier today to really show the advances, the things they've learned through everything and how they're taking each and every one of those things, those lessons learned, and putting it into all of the STA improvements as we go forward. The refurbishments are purely based upon those efforts. And, again, back to the tech rep meeting groups, I'm looking forward to seeing the studies that are remaining, getting the results of those, and seeing how we can further advance the STA science. So, looking forward to this conversation. Thank you.
Right, thanks, Ed. And Bill, you have the floor.
So Bill Walker is having some technical issues, but Bob Cadillac is here with us on the panel. So maybe we give time to Bob.
Yeah, and Bob, I was just writing a message to Stephanie. I'm sorry that I missed you in the introduction to the panel. So you have the floor.
Hey, thank you very much. I'm sorry to be somewhat of throwing cold water on much of what is being said, but I'm going to offer some opinions based on my experiences over the last 30 years in tracking how the STAs are functioning and trying to figure out more about what makes them tick. So I'm going to offer 3 opinion statements, but you're surely aware that I have filed some documents and a summary that time does not allow at this particular oral presentation. First, under the status quo, I don't think the Q bill will be met. There are a lot of current remedial activities, but few remaining restoration strategies, systems additions that remain are not going to be adequate. Furthermore, I think that lake water relief measures may well exacerbate the STA inadequacies. Point number 2, there is an enormous amount of science that has been gained through restoration strategies and a host of other projects. However, what's missing, I think, is a synthesis of that vast STA knowledge into proposals and evaluations of candidate operational changes and retrofits. I'm well aware that there are some such things in progress. Thirdly, I would offer that the principal obstacle to progress is bureaucratic institutions and procedures. I sense, along with other folks, that legal, political, and economic consequences have cut off avenues of scientific communication and promising avenues of STA re-engineering. So unless there is a change in the status quo, I think we're not likely to meet the conditions required in 2026. Thank you.
Right, I think given that, I'm going to give Jennifer or Ed or Bill, if you're on, just a chance to respond to Bob briefly, if you'd so desire, before I go to questions from the committee.
Well, this is Ed Smith, Jen. I'll go first, I guess. You know, while the QBEL has not been met yet, I think it's important to, again, going back to Cassandra's presentation, to highlight that the STAs, while yes, there's certain pieces of restoration strategies that we have been able to pass those milestones, they're not fully operational at this time. And so there are significant portions of each and every STA that are being worked on. And because of that, you know, there's a missing piece of that treatment train, if you will. So the department is pretty confident that once all of those components do come online, the QBEL will be met. With that being said, you know, the QBEL is a Clean Water Act component, and therefore, you know, it has a mechanism built in to it that has been through the ringer. It's gone through all of the legal opportunities, and we feel confident that by just staying within that QBEL framework, we'll be able to achieve the QBEL in the long run. So with that, I'll pass off to Jennifer.
Yeah, I think I'm interested to hear the question and answers from the committee, particularly related to some of Dr. Cadillac's opinions, because, you know, he's on the foundation of this entire program. And so his opinions are really important, I think, for us to understand and to appreciate. And although he hasn't been maybe working with some of the most recent scientific data that we've been putting together, as I mentioned, he was, you know, at the start of this and part of the team that helped develop and review our science plan. And so there's a huge group of scientists and engineers and experts that have been part of this program, and Dr. Cadillac is one of those. And so I think it's important for us all to think about these hard questions. That said, I totally agree that the status quo wouldn't get us there. And that's why we're committed to doing the refurbishments that Ed Smith was just talking about, as well as finishing the projects. If we only moved forward with finishing the projects that were originally conceived in restoration strategies, we wouldn't get there, because many of those projects were initially built only to achieve, 50 parts per billion. Well, we have to achieve a much more stringent water quality standard than that. And we recognize that, and that's why we're retrofitting, you know, every one of the projects that we have in order to achieve those higher standards. And so with that, I also agree that there's a lot of bureaucratic process that's associated with water quality, with CERP in general, and with how the agencies work together. And although that's a huge issue, and I think some of our biggest challenges are actually in that arena, I'm also aware that, you know, those are areas that aren't really the purview of this committee. And so we are tackling those bureaucratic challenges in other fora, and the agencies are working very hard together to try and break down some of those hurdles and not let those things be the areas that are holding up or delaying Everglades restoration.
Thanks, Jennifer. And I'm sure your military training is helpful in that. If we can go to committee questions, and committee members, I would ask that when you ask the question, you maybe identify if there's a primarily one member of the panel that question is directed to, so that they can sort of be on the lookout to respond. But other panel members, feel free to also chime in a response. Just, you don't have to indicate to me, just chime in. So we will kick it off with Eaa.
My question is to Dr. Cadillac. Just wanted to ask if you have specific recommendations about restoration strategies that you believe that to be effective, but they aren't being pursued at the moment, then the state could consider.
Is that a question for me?
Yes, sir.
Okay. Yes. Well, there definitely are some things that I think could be done differently. And as a matter of fact, there is a document which I filed with the district, I believe about 2 years ago, that outlined a set of priorities that represented my view of how restoration strategies would be better spending their efforts. So I don't have that at my fingertips as we speak. It dates back to about 3 or 4 years ago at the time of the last 5-year reorganization of the science plan process. So in fact, what you're asking for, I have put in writing.
I don't have that document at my fingertips at the moment either, but that's something that we can provide to the committee. And so we'll put that together and pass that on to the committee as well.
Okay. Committee members?
Denise, Al here. I'm just, again, to Bob and to Stephanie, is that the memorandum that we had received as part of this package that had Bob's STA observations? Is that one of the same? Or are you talking about a different document?
It's a different document that's vintage 5 years ago.
Okay, thanks, Bob.
Mm-hmm. Okay, thanks, Alan. Jeff?
Yeah, my question, I guess, is for anyone. So you have a way that you want to operate the STAs, but things happen and sometimes you can't do what you want to do. I'm remembering issues with snail kites nesting in STAs and other birds nesting in STAs and unpredictable weather. What are the things you worry about, sort of extraneous things that could happen that could compromise what you can achieve with the STAs?
Yeah, that one's probably for me. And so I'll take it first, and Ed, I might look to you to add anything. But those are exactly some of the types of things that we're worried about, right? So on one hand, we think about the STAs as a piece of really critical engineering infrastructure that allows us to manage water levels and achieve our water quality based effluent limits and move water in terms of volume and quality into the Everglades. On the other hand, right, then you also have the STAs as this semi-natural but managed ecosystem that attracts wildlife, that is enjoyed by all kinds of species, including some that are listed. And so we have to work very closely with the U.S. Fish and Wildlife Service, as well as the Florida Wildlife Commission, in managing those areas so that we can create that balance. And so some of those things are what we worry about. And one of the things that we're working really hard with the service on right now is developing more regional management across our biological opinions and looking at the greater Everglades as a system and recognizing that there needs to be changes over time as the system becomes more resilient in certain areas, becomes better habitat in certain areas for certain species, and that there's going to be transitions over time. And so the service is committed to working with us and the other agencies on that. And so with the support from the Department of the Interior, we're working closely to manage that. But those are some of the things that you brought up are exactly the things that keep us up at night.
I might point out that about 20 years ago, US EPA offered a document on how water treatment goals in wetlands could be made more compatible with ecological goals. And at that time, that document, which is, I can't quote the number, but I can provide it if anyone's interested, it simply said, if you want to meet both ecological and water quality goals, you must overbuild the system to accommodate both uses. And in the case of the STAs, an allowance had been made during design, which forecast that there would be about 5% quote downtime due to issues like ecological management. That 5%, I think, was an underestimate. And I think that the strategy, if you really want to have multiple goals and not prioritize them, has to be that the cost of additional works must be borne outside the water quality effort.
Ed, did you have anything you wanted to add?
Well, I was just going to, again, kind of feed off what Jen Reynolds mentioned, that, you know, the STAs, just so everyone is aware, they do have an NPDES permit, a National Pollutant Discharge Elimination System permit for them. It is the equivalent of an industrial wastewater treatment plant permit. The industrial wastewater treatment systems are typically designed so you can operate them to maximize treatment. You can twist knobs, turn this, redirect water, do everything, and you can meet compliance points. You can meet your discharge limits. The STAs, even though they're permitted as that, they bring in unique challenges that an industrial wastewater plant doesn't have. And so I think, you know, taking into consideration what the lessons have learned from the district and future operations, I think they're doing a phenomenal job in addressing some of those concerns. But they are, you know, the natural challenges that are out there, either, you know, nesting birds or whatever, certainly do. They make the game interesting and exciting for everyone when it comes to operations. But I think based off the science plan, what we've been learning, we have the tools and we're developing more tools in order to overcome those challenges.
Jeff, is that okay? We'll go to Bill and then Ramesh and then Charlie.
So I think this is to Jennifer so my take and sort of listening to Cassandra's presentation, your take on it is that you're confident in each of the SDAs, you're going to get to the WQ bill, looking ahead to, you know, when all the additional components are in place. So like SDA 5.6, which has been problematic. I mean, there's lots going on there, some refurbishment of 5.6, FEB, the 139 FEB, to buffer a connection to Lake Okeechobee water and so forth. And so I guess my question was, and then of course there's others who have voiced some less confidence, I think, than the district has, but we don't have access to, you know, all the information analysis you do. So I guess I was wondering, are there SDA by SDA analysis that have been done and synthesis that would take like the SDA 5.6 and say, okay, we have the FEB there, we have Lake Okeechobee water coming in with these different constituents, and you know, given the kind of performance that we've seen and we understand, and these levels of flow that you get down to that WQ bell? I mean, are there those kinds of analysis out there that sort of put all that together and digest it and synthesize it and then lead you to feel, yeah, we can achieve each of those in 5-6 and then 2 and 1 west and et cetera. So
yeah, so we are doing that analysis, not just STA by STA, nor flowway by flowway, but cells within each flowway,
right, exactly.
within each
Yeah, it's a
STA, within
complicated,
each of the restoration strategies flowways, right? So we are digging deep into the analysis in every area. And Jose, I might put you on the spot here in a second to talk a little bit more about this. But yes, we are absolutely doing that. And that's why we feel so confident that we have figured out, not just from modeling, because quite honestly, the modeling that we have is not very precise when you start getting down to these low numbers, right? So when you're trying to figure out, are we going to be at 7, 10, or 12, the models don't help us out that much. They're just not sensitive enough when you get down there. So we're having to really rely on observed data. And our scientists are taking that observed information and really taking a look at, okay, isolating different factors and saying, okay, what happened here? What happened here? What happened here? But as you know, with any living system, there are factors that are hard to isolate. And there are going to be things that happen that we won't be able to describe fully until we have more data and more of these systems in operation. But we've already seen demonstrated success with the improvements and with the structures and with the operations that we have in effect. And so that's why we feel so confident that we know how to get there. And we know how to keep making those incremental improvements as we get more data and we operate more, and then we can continue to do refurbishments and to do tweaks that help us operate better, achieve better performance, and continue to replicate these kinds of systems across the landscape in order to deliver more and more clean water, and not just south of the lake, but we're implementing stormwater treatment areas north of the lake as well. And we are taking these lessons learned and applying them there. And so, Jose, I don't know if you have anything that you'd like to add. I'll take that as a no.
Oh, there he is. Jose, you're muted.
Oh, no. Yes, I was muted. Yes, I can add a couple of things. The model that we've relied on for planning these facilities does not account for dry out. And dry out is a very important factor for the lack of performance in STA 5.6. So the ability to bring water, to have these cells not go through a dry out period, not just drawdown, but actual dry out where oxidation of soils occur, the ability to avoid that is critical. So the FEB that's being built currently is going to help with that. That FEB is relatively small compared to the size of STA 5.6. A1 FEB is about the size of STA 3.4, but the C139 FEB is relatively small compared to the size of STA 5.6. So then the connection to Lake Okeechobee becomes very critical, and we're beginning the design phase to make that happen. So that's going to be a very important factor to improve the performance of STA 5.6. Mm-hmm. The other factor I wanted to mention is STA 5.6 serves the C139 basin, which has a very different hydrology than the other STAs. The other STAs have a very typical wet season, very well-defined wet season. C139 has it built-in storage, which the EA does not.
the Eaa, when it rains, the pumps go on and water reaches the STAs right away as a flood control runoff event. The C-139 takes time to receive water. And once it does, it never stops. It just keeps on going. In fact, just about 1 or 2 weeks ago, all of our STA pump stations were secured, that means turned off. The one at STA 56 was still going. So it is different in hydrology, and the model wasn't able to capture dry out. So we have to address those two things by avoiding the dry out, by doing this refurbishment component, which is the connection to Lake Okeechobee, completing the FEB, and doing things in the process to avoid the peaks that occur after a dry out. For example, something we implemented this season is as the wet season began, we primed all of the 8 flowways of STA 56. Basically, put water in, but don't let water out. Try to put water in every one of them. And only when they were pretty much ready to overflow, the gates were slowly opened. Normally, we wouldn't do that in STAs, flow in, flow out. But we had to do something different until we have that connection and that avoidance of dry out. We have to do those sort of temporary measures. That's all for now.
Yeah, thank you, Jose and Jennifer. Thank you very much.
Yeah, thank you. I will go next to Ramesh and then Charlie. You're on mute, Ramesh.
Thank you, Jennifer, for all your comments. Really greatly appreciated. I do kind of, with mixed feelings, I disagree with the expectations. I do agree with Bob Cadillac to some extent. So here's my reasoning. I think even if I use the STA 3 and 4, my best option right now, the loading rate for that one is about less than 0.5 gram per meter square per year. Even at that rate, first half of the cells are actually now pretty phosphorus enriched. Most of the treatment now is happening on the second half of the flow path. So given those kind of situations, you had to really make some drastic changes in all the other STAs to meet the QBEL by STA. I don't think the plans are not there. Even if you implement all the best plans, this is the biological system we're talking here. It's not a chemical treatment plant. So the biological system practically will not function the way we want. We may get close. We may get close to meeting the QBEL, but I don't think we can really say confidently now that we'll meet the QBEL. So it has to be very adaptive, to go by year and see how we really manage these systems, whether we can actually achieve the goal we want. So two things, the loading rate has to be changed, right? So all of them has to be drastically, we don't have a long enough flow path to treat the water the way we want it. If you were to compare WCA2 pre-STA flow path, first 4 or 5 kilometers is, as you know, is all impacted by with phosphorus enrichment was there and the cattails dominated. And you compare that flow path, now you compare that flow path to STA 3 and 4, the first half of the cattails, they're exactly the same. They actually parallel each other with respect to phosphorus retention. So that tells me that we don't have long enough flow path in STAs in relation to their loading rate. STA 3 and 4, if you can bring everything back to STA 3 and 4, you may have a chance. But do we have plans to do that one? So I do not know, but I don't think that was presented in Cassandra's presentation, but the expectations are very high. And I hate to see we get disappointed if we really don't reach that goal.
Yeah, so I can try and address that a little bit, and then I might have to call on others. So, you know, as we looked at restoration strategies and all of the modeling that we have done and the work that was both planned and existing in the ground, we had a factor within that modeling to that we made some conservative assumptions. And according to all of that work, restoration strategies alone meets the QBEL and is in accordance with everything outlined by EPA standards and by the state's water quality directives. And so we designed all of restoration strategies to do that. But we wanted to make sure that we had a larger margin for error. And we knew with these biological systems that things happen that you can't control. And so that's why we took on efforts to do more, to do additional refurbishments, to do additional projects, and to do additional work that would create an increased buffer to allow us to do things like accommodate for areas that we might not be able to control as well in the limited time frame that we had to complete all of these efforts. And so we feel like we have done so much more in order to accommodate those things, but I can appreciate that that people have reservations or concerns about it because there's a lot of stuff coming together very quickly. And there's been a lot of work just in the last 5 years that is tremendous. And you're not really seeing all of the data to support all of the things that are going on, but we are already analyzing the data that we have. And like I mentioned, looking at each of the different cells within the different STAs, within the flowways, and really digging into, is this working here under the operational regimes that we will foresee in the future? And they are. Now we just have to keep replicating it, but it's very hard to see without digging into that data right now because we have almost everything under construction. And so you don't have so many areas that are operating the way that they will be 6 months from now, a year from now, 2 years from now. And so I think that as more of that data comes in, it will be more transparent to the rest of the folks that aren't maybe living in this every single day.
Thanks, Jennifer. I will go to Charlie.
Thank you. My question is a little bit down in the weeds, but I was really intrigued by Cassandra's presentation where she presented information on different fractions of phosphorus and the relative removal efficiency. So it seems from the information that was presented that the STAs are fairly effective at removing the particulate fraction and the soluble reactive fraction, but less effective in removing the organic fraction. So I guess my question is, and maybe you can't answer this, but I was curious how these different fractions vary across the systems, and when you see events, are there insights that you can get by looking at the individual fractions and maybe the challenges associated with removing the organic fraction that will provide you insights in terms of achieving the phosphorus, the total phosphorus removal that you want in the effluent?
That's a really in-depth question, and I appreciate that. This is Cassandra, by the way. So yes, we are looking at the different fractions and their locations. As you mentioned, the phosphorus particulates are primarily up in the upper part of the treatment train where the organics really dominate towards the bottom. We actually have a study, a bioassay study ongoing right now to look at the bioavailability of the organic fraction and to see how and if it can be broken down so that it can become more available to be taken up. As you remember, the calcium did not respond with the DOP to precipitate out. So if we can crack the DOP a little bit and turn it more into the inorganic forms, maybe we can get it to precipitate out in the lower end. One of the other things that we're looking at is during storm events or wind events, we get entrainment of the particulates, and especially at the bottom end, where we've got a lot more open water than we do up in the upper emergent dominated area. So we've been working with our vegetation management folks to take a look at doing buffer areas of emergence towards the bottom, so that if we do get entrainment of those particulates during a storm, they'll hit an emergent area before they go through our outflow, which is where we measure our performance. So hopefully that can pull that fraction out before it actually goes out the outflow for these one-off types of events that we obviously can't control those. So we are working on how to manage the different fractions a little bit better so that we can get to QBEL. We're working on it, work in progress, but it's definitely in our minds. And like I said, we have some ongoing studies to focus on just that.
Okay, thank you.
Great. I have Phil, then Deidre, but I did want to tell the panel that before we leave, I want to ask you each if you can give us one way that this Science and Technical Advisory Committee can best advance, support, and facilitate meeting the QBEL. So I'd just like your brief thoughts on that before we go. But with that, we'll go to Phil, and then Deidre, you'll be on deck.
So one of the standard pieces of advice when there is scientific disagreement is to consider a more formal adaptive management plan. And I'm a little worried that there may not be enough time between implementation of what you are hoping will achieve QBEL and what I understand is a regulatory deadline of 2026. Is there some way to try to build in flexibility with what little time there might be between completion of the current construction and bringing online of the facilities and assessment of whether they in fact are doing what you're hoping that they will do and meet QBEL expectations?
Can I please chime in quickly on that question? I think one of the things that's been overlooked is that these huge SDAs with vast soil phosphorus storages do not respond quickly to any management efforts. If you only have to look at the length of time it is taking the northern end of 2A to respond to remedial actions and lowering phosphorus going into it. The trouble with adaptive management is if you have to wait years to get the potential effect, it makes life meeting a QBEL in a few years impossible.
I certainly don't disagree in systems with long lags.
Jennifer or Ed, did you want to respond?
This is Ed, sorry, I was muted. I think not arguing against what Mr. Cadlick said. He's certainly right. The systems do take time to respond. I think everybody agrees that is inherent in the STAs. But again, it goes back to the district has already started to implement some of the things they've learned, which are, what I would consider to be equivalent to an adaptive management protocol, if you will. They've recognized that certain cells are not functioning, and they've done the research to figure out why those cells are not functioning. So they've already begun the work fix those things. All of these little tweaks around the edges, if you will, I mean, I call them tweaks, but they're multi-million-dollar enhancements to these systems that are being incorporated right now. And again, back to the QBEL itself, Ken Bradshaw's presentation highlighted the fact that there was a conservative factor built into the modeling. And so there is a level of comfort, I guess, if you will, in the QBEL that it will be met. So I think we agree that more work needs to be done. We're not there yet, and we have a long way to go. But the adaptive management thing, I think the district is already really seriously implementing some of the lessons learned through that process.
Okay. Phil, are you good?
Good. Thank you very much.
Okay. Deirdre?
Yes. So I was just going to ask, kind of respond to your request, Denise, about, what we're thinking about things is, I'm still trying to get all this in and try to learn. So right now I don't have any recommendations, but my question is in an effort to get me there. And my question is not in the weeds. It's actually kind of a bird's eye view or perspective. So to help a new person on the committee, just kind of understand if the committee could maybe give me some, well, first, someone mentioned, it may have been Jennifer, that, the work that's being done is, kind of unprecedented and not being done anywhere else. And I was just wondering if you could give me just a couple of, results of projects that you're really proud of, and then, and things that kind of lend to this unprecedented work, and then, some of the challenges, because right now I'm just really overwhelmed in what I'm hearing. And so I was just hoping I can get some bullet points on what are some major accomplishments and some major challenges. And that's to anyone.
Yeah, I'm not even sure where to start, because every one of these STAs, so if you just take any one of the STAs, they are on a scale that dwarfs water quality treatment projects that are being done anywhere else. So these are water quality treatment projects that are not only moving tremendous amounts of water that are on the scale of, flood control project level movement of water, but then they're biological systems that are operating as habitat across our Everglades. And so both of those aspects are really unprecedented when you look at water quality projects across the nation and across the world. And so we have many different agencies and organizations that are coming to us asking for our information and expertise, and we're presenting that in papers and presentations across technical conferences and publications. And so I can absolutely give you some maybe more high level bullet points and kind of some snippets from some of our presentations that might be helpful just to kind of wrap your brain around the scale of some of these things. And so we'd be happy to do that.
Okay.
I'd like to also recommend the SFER over the years that really highlights all of the activities, the successes, the current statuses of all of the STAs. Both there's a couple different chapters, but you can see the projects that we're working on and the successes. And then in the appendices, we have all of the projects that we really like to highlight as our successes. So, and that's all available on our website.
Okay.
Great, thank you. Let's see if, are there any other questions from committee members? And seeing none, let me just go around and to each of the panelists again, ask you the question if you could identify, Jennifer, it sounds like you might have a lot, but if you could identify one way in which this committee could best facilitate and support meeting the Q bell, what would that be? And I'll ask Jennifer first, and then Ed and Bob.
Yeah, I think, so thank you for that. And I really appreciate the question. And it kind of gets at Phil's question earlier that he asked, because what we would probably most benefit from the committee is if you could focus not so much on the biogeochemistry, because that's something that we can't do a lot about to control. And so, but looking at, are there engineering recommendations that the committee would have that we could implement that would help us to optimize the treatment train? So rather than, focusing on the things we can't control, helping us focus on the things that we can control and see if there's any recommendations that you would have in that arena.
Thank you. Ed, do you want to make a suggestion on what the committee from your end might be able to focus on that would be helpful?
And I really can't think of anything. I think Jennifer kind of hit the nail on the head. Those things that we can control or what would be most helpful. We're always looking for ideas, options, opportunities to improve performance. So, if they have come across something in the past, that certainly would be welcome. But again, it's limited to those things that we can control. Those things we can't control. Those are the biggest challenges. So.
Okay. And Bob, you get to be the last voice on a recommendation for the committee. You're on mute. If you're speaking, you're on mute.
Sorry about that. I'm now unmuted. I may surprise you. I'm going to agree pretty much with what Jennifer said with a caveat. And I think the best thing that the committee could do is to emphasize the engineering aspects of the STA knowledge base and operations, and do so in a transparent way involving stakeholders who are listening to this presentation but are not part of it. And to that end, I'm suggesting we've got a lot of science, more, has been pointed out, more than anyone else could ever hope for. There are over 1,000 papers on these projects. And stop the science and start the engineering. And for heaven's sake, don't close out cooperative stakeholders.
Thanks, Bob. That was well articulated. Barring any last minute things, let me vociferously and enthusiastically thank our speakers and panelists. This was quite a briefing to start off with, and I really appreciate it. I think you gave us a tremendous amount of very relevant and succinct information. Formally, there were, I know, lots of people on the line, but let me thank Ken and Cassandra and Jennifer and Jose and Becky, who was kind of on board, and our panelists, Bob and Ed. And again, Jennifer, it was very informative. So the last slide is up, the upcoming meetings. And again, there's a link there to register to find out more information. And with that, I'll adjourn. It's 1 o'clock and thank you very, very much.